Okay, in this lesson, we're going to be talking about partial fractions. So a lot of times it seems like in math, in one lesson we'll do something and in another lesson we'll undo. And that's kind of like what's happening here. A rational expression can often be written as the sum of two or more fractions, called a partial fraction decomposition. So we are going to take a fraction and we're going to decompose it into the sum or difference of two other fractions. Now, we know that in previous lessons, a few chapters ago, that we took those two fractions, we add them together by finding the common denominator and put them together to give us this. So now we're going to work this problem backwards by decomposing it. Now, this is helpful a lot of times in calculus whenever we are looking to integrate is one of our main uses for this. The individual fractions are called partial fractions. And that's what we are doing. A rational expression is proper when the degree of the numerator is less than the degree of the denominator. Follow the steps below to decompose this proper fraction. So step number one, we're going to factor the denominator. So our denominator is going to factor into two sets of parentheses. Adds, multiplies will be a positive 2 and then an x plus 4. Step number two, we're going to write the expression. Let me go ahead and do this. Write the expression as the sum of two fractions using a and b as the numerators and the linear factor as the denominator. So we're going to take 3x plus 2, our original problem, 3x plus 2 over x squared plus 6x plus 8. And we're going to decompose that into something over x plus 2 plus something over x plus 4. So use a and b as the tops and then use these two factors as the bottoms. Next step, we're going to use our common denominator, which we know is going to be pretty much this, x plus 2 times x plus 4. This is our common denominator, and we're going to multiply everything by that common denominator, x plus 2 times x plus 4. Here, everything cancels and leaves you with 3x plus 2. Oops, there we go. Here, the x plus 2's will cancel and we'll leave you with an a times x plus 4. Plus, here your x plus 4's will cancel and we'll leave you with a b times x plus 2. Step number 4 says distribute and group like terms. So we now have 3x plus 2 is equal to ax plus 4a plus bx plus 2b. And we're going to group our like terms. So we have 3x plus 2 equals, we're going to group our ax and our bx, plus we're going to group our 4a and our 2b. And let me go ahead and do the next step as well. I'm going to move that up so we have room for one more step. We're going to factor the x out of that first group of terms. Hang on, let me try that again. 3x plus 2 is equal to, factor out the x, and you're left with a plus b, plus, and we're just going to group our 4a plus 2b together. And here's why. It says write a system for the equations to find a and b. Notice here 3x pairs up with this because that's your x stuff. So therefore, what we're going to do, we're going to pair these two things together, and we're going to pair these two things together. In order for this to be equal to this, then a plus b here would have to equal 3. And this stuff over here would have to equal 2. 4a plus 2b has to be 2. So notice what you have now. You have a system of equations. We're going to solve our system, and it says using a method of your choice. You can use substitution, use elimination. I'm going to go ahead and use elimination. I'm going to multiply my first equation by negative 2. Use your negative 2a, negative 2b, and negative 6. Second equation stays the same. And when I add these two equations together, I now have 2a is equal to negative 4. So therefore, a would be negative 2. That's half your answer. And when you plug a equals negative 2 back in, you find out that b is equal to, let's see, negative 2 plus 5 would be 3 there. So there's your B value. It says write the partial fraction decomposition of the expression now. If you'll go back and look, here is your partial fraction decomposition. We were going to break it down. We're going to break down our original into a over x plus 2 plus b over x plus 4. So we now have it a over x plus 2 plus b over x plus 4. And you could write either term first, so that's one way of writing it, or you could have done 5 over x plus 4, and since the 2 is a negative, put minus 2 over x plus 2, and either one of those answers would be fine, and you've decomposed your fraction. Okay, now let's work a few more examples. Decompose the following fraction, 7x minus 15 over x squared minus 9. The bottom factors into x plus 3 times x minus 3. So we're going to write our 7x minus 15 over x squared minus 9 as a over x plus 3 plus b over x minus 3. Again, we multiply everything by our common denominator. Once you do, things will cancel, and here's what you're left with. It'll be a 7x minus 15 equals, the x plus 3's will cancel here, and we'll leave you the x minus 3. The x minus 3's will cancel here, and we'll leave you with the x plus 3. Distribute your a and b. You now have 7x minus 15 equals a times x minus 3 times a plus b times x plus 3 times b. Group your a's, or excuse me, group your x stuff and your non-x stuff on the other side. Gives you 7x minus 15 equals ax plus bx minus 3a. Let me try that again. That looked pretty sloppy. Minus 3a plus 3b. Factor out the x stuff here, and I'm just going to write this. When you factor out x here, that's going to be x times a plus b instead of rewriting the whole thing. Now group your x stuff with your x stuff, and that shows me that a plus b, and I'm going to come over here to write this. A plus b has to be 7, and this stuff has to be negative 15. So negative 3a plus 3b has to be negative 15. Solve the system, and I'm not going to go through the steps of solving it, but when you solve your system with either substitution, elimination, Kramer's, graphing, so many methods now. You could even use reduced row echelon form. We have so many methods of solving it, but when you do, here's what you get. A equals 6 and B equals 1. And instead of going back and rewriting everything, you can just come up here and in the place of A, put a 6, in the place of B, put a 1, and there is your fraction decomposition. Okay, example number 2. Again, we're going to factor the bottom, and we're going to use slip and slide method to do it. That's going to be x squared minus 7x plus 6, which factors into x and x, a negative 6 and a negative 1. We move the 2, so let's now divide by it. And you now have x minus 3 times 2x minus 1. So therefore, let's go ahead and write negative 7x minus 9 over 2x squared minus 7x plus 3 equals a over x minus 3 plus b over 2x minus 1. Again, we're going to multiply through by our common denominator, which is always going to be right here. When you do that, let me change colors here. When you do that, you're left with negative 7x minus 9 over here. Your x minus 3's would cancel here, and would leave you with the a times 2x minus 1. Here, your 2x minus 1's would cancel and leaves you with a b and the x minus 3. Distributive property gives you 2a times x minus a plus bx minus 3b. Let's group our x stuff together, and while we group it together, let's go ahead and factor that x value out. So you'll have x times 2a plus b, and then everything else we're just going to group together as well, and that would be a negative a and a negative 3b. match up your x stuff, and that shows us that 2a plus b will equal whatever's in front of the x, which is a negative 7. And our constant term will equal this constant term. So negative a minus 3b will equal negative 9. And simply solve this system any method that you want. Again, you can type it into your calculator if you'd like to. Use reduced row echelon form. You can use substitution, elimination. But anyway, regardless, you're going to find out that a is equal to negative 6 and b is equal to 5. Therefore, here is your partial fractions. A is negative 6, b is 5. That's what it breaks down into. Okay, example number 3. Again, let's factor the bottom. A little bit tougher here because you have 3 factors on bottom. X times x squared minus 2x minus 3, which will be x times 2 sets of parentheses, x minus 3, and an x plus 1. So therefore, we're going to decompose this into, let me go ahead and rewrite our original problem, is equal to a over x plus b over x minus 3 plus c over x plus 1. Okay, now we're going to multiply through by our common denominator. On the left side, you're just going to be left with the numerator, negative 5x squared plus 19x plus 12. Everything else cancels. On the right side, the x is going to cancel here, and you're going to have the top times x minus 3 times x plus 1. Plus, here the x minus 3s are going to cancel, and we'll leave you with b times the x and times an x plus 1. Plus, here the x plus 1s will cancel and leave you with a c times an x times the x minus 3. Now let's go ahead and distribute that to start cleaning it up. You now have negative 5x squared plus 19x plus 12. We're going to distribute this, and I'm going to do it actually right here above it to save ourselves a step. That turns into x squared minus 2x minus 3. When you distribute the a with it, you now have ax squared minus 2ax minus 3a. When you distribute your bx here, you have bx squared plus bx. And when you distribute your cx, you now have cx squared minus 3xc. Let's combine or put together all of our x squared stuff. And we find out that we have, let's factor it out as we put it together, x squared times a plus b plus c. Let's put our x stuff together, which is here, here, and here, and factor out the x as we do it. So factor out a positive x, and we have negative 2a. We have a positive b, and we have a negative 3c. And then let's put our constant terms last. And let's see, is that our only constant term? Looks to be a minus 3a. So next up, we simply set our corresponding pieces equal to each other. Here's our x squared term. Here's our x squared term. So therefore, that tells me that a plus b plus c has to be negative 5. Our x terms are here and here, which tells me negative 2a plus b minus 3c has to equal 19. And our constant terms here and here tells me that negative 3a has to equal 12. Which goes ahead and shows you what a is equal to. Obviously, a is equal to negative 4 from this, and you could use substitution, back substitution in to try to find b and c. However, you can also use RREF, reduced row echelon form. Regardless, a, b, and c are equal to negative 4, 2, and negative 3. So therefore, my partial fractions up here are negative 4 over x, 2 over x minus 3, and negative 3 over x plus 1. So you could actually change that plus and just put your minus out there, and there is your partial fractions. Example 4. Let's do it again. Let's factor the bottom. Looks like we might be able to factor by grouping. So let's factor out an x squared out of the first group, and you're left with x plus 2. Factor a negative 25 out of the second group, and you're left also with x plus 2. Factor the x plus 2 out of both groups. You're left with x squared minus 25, which is difference of squares. So you now have x plus 2 times x plus 5 times x minus 5. So therefore, our fraction, let me go ahead and rewrite the original problem. We are going to decompose into something over x plus 2 plus something over x plus 5 plus something over x minus 5. So here we go. Go ahead and multiply through by your common denominator. Over here, everything cancels and only leaves you with the top, 31x plus 75. Here, your x plus 2's cancel and leaves you with simply the x plus 5 and the x minus 5. Here, your x plus 5's cancels and leaves you with the b, the x plus 2, and the x minus 5. And here, your x minus 5's cancel and leaves you with the x plus 2 and the x plus 5. Let's go ahead, and I'm going to multiply them out right above it just to save us a step. This multiplies out to x squared minus 25. This is x squared minus 3x minus 10. And this is x squared plus 7x plus 10. So now let's go ahead and distribute our a's, b's, and c's. This left side will stay the same. And here you're going to have a times both of these will be ax squared minus 25a. Distribute your b times all of this gives you plus bx squared minus 3bx minus 10b. And c times all of this gives you plus cx squared plus 7cx. And it doesn't matter which one you put first, plus 10c. So our x squared group, we're going to put all three of these together, and that shows me that a plus b plus c, when you factor x squared out, is what you're left with. Then let's group our x stuff together. That's x stuff, and here is some more x stuff here, and I believe that's it. So you have plus, when you factor the x out, you're going to have a negative 3b and a positive 7c multiplied by x. And then your constants terms are here, here, and here. So you have plus your constant terms, which is a negative 25a, a negative 10b, and a positive 10c. So now let's set our corresponding pieces equal. Here's our x squared stuff. So that tells me that a plus b plus c will have to equal a negative 8. Your x stuff is here, which tells me the negative 3b plus 7c would have to equal a negative 31. And then your constant stuff, negative 25a minus 10b plus 10c would have to equal your constant over here, which is 75. So there is your system. And when you solve this system, you get a is negative 5, b is 1, and c is negative 4. So therefore, my partial fractions, a, b, and c, I can put a negative 5 for a 1 for b, and a negative 4 for c. So if you'd like to put that minus out front, this is your decomposed fraction. Okay, next example. Example number 5. Again, we're going to factor the bottom first. It looks like we can again use factoring by grouping. So we're going to factor out a 16x squared. You're left with x minus 2. Factor out a negative 1, and you're also left with x minus 2. Factor out an x minus 2 out of both terms, and you're left with a 16x squared minus 1. And we're going to do just like we did on the last one. That's difference of squares. Difference of squares factors into conjugates. 4x times itself gives you 16x squared, and 1 times itself gives you the negative 1. So therefore, we're going to take our original fraction, and we're going to break it down into a over x minus 2 plus b over 4x plus 1 plus c over 4x minus 1. Okay, next up, let's go through and multiply everything by its common denominator. So you're going to be left with just the top here, 12x squared plus 67x plus 7. And again, right here is your common denominator. When you multiply this times the common denominator, x minus 2's are canceling. Leaves you with the a, the 4x plus 1, and the 4x minus 1. Plus, when you multiply this, the 4x plus 1's cancel and leaves you with the x minus 2 and the 4x minus 1. Plus, when you multiply this, the 4x minus 1's cancels and leaves you with an x minus 2 and a 4x plus 1. Let's go ahead and distribute or FOIL these out. You have a times, and I'm just going to bring this other part down instead of rewriting it. That'd be 16x squared minus 1 plus b times, when you FOIL this, that's going to be 4x squared. Let's see, that's going to be negative 8 and negative 1, which would be a negative 9x plus 2, plus c times 4x squared. That'll be a negative 8 and a positive 1, which would be a negative 7x minus 2. Again, now just continue bringing this down. We're going to distribute our a, and we have now 16a x squared minus a. Distribute your b is going to be plus 4b x squared minus 9bx and plus 2b. Distribute your c gives you a 4cx squared minus 7cx and a minus 2c. So now let's go ahead and group our x squared stuff together, and let's factor it out. There's x squared. So we're going to factor the x squared out, and I'm going to write it at the end. So we have a 16a, a positive 4b, and a positive 4c when you factor out the x squared. And again, I'm just writing the x squared at the end instead of the beginning. Next up, you have, that's a constant, your x stuff, which is here and here. So let's group those together, and I'm going to put a plus out front. And when I factor the x out, I'm left with a negative 9b, and I'm left with a negative 7c when you factor out the x. And I should be left with all constant stuff with no x's, and I am. So I have plus a negative a positive 2b, and a negative 2c. Now that's equal to, again, I'm going to bring my 12x squared plus 67x plus 7 down. I'm going to group my x squared stuff together, and that tells me that 16a plus 4b plus 4c is equal to 12. Your x stuff grouped together gives me a negative 9b, and a negative 7c is equal to 67. And my constant terms are going to equal negative a plus 2b minus 2c, and that is equal to 7. So there's your system. And once you solve the system, you find out that a, b, and c are equal to 3, negative 2, and negative 7. So let's go back up here and replace a with 3, b with a negative 2. So I'm going to put the 2 here, and I'll just change my plus sign to a minus, and c with a negative 7. So therefore, there is my fraction decomposed, my partial fractions.